Alrighty, so we're going to be going over our third lesson, the first one of the day, and the topic is going to be properties of slopes of lines. Alright, so we're going to be looking at kind of the changes we can make to our slope and what that's going to do to the look of our line when we put it on a graph. Alright, so it says enter each equation and sketch a copy of the graph below. Use the table of values to determine the slope of each line. Now, we're not going to use a table of values. I'm going to show you how to create a table of values on Desmos, but we're actually not going to use it because we already learned from yesterday that the number in the equation is our slope, right? So we already know that 2x, that our slope has to be 2. And if you have the equation y equals 1x, or this could be written as y equals x, that would have a slope of 1. And the last one here, y equals 1/2 x, will have a slope of 1/2. And we can kind of predict what we think is going to happen. We can see as we move over to each equation, our slope is decreasing. So I'm already going to predict that when our slope decreases, all right, our line becomes less steep each time. So let's see what happens. So back over to Desmos. So the first equation was y equals 2x. And just quickly to show you, let's say you want to make a table of values of this equation. In Desmos, if you hit the little wheel after you've typed in the equation, you can see now we get this little table icon that shows up, the first one on the left, and if you hit that, all right, we get a nice table of values of our equation. All right, but we're not going to actually use that today. I just thought I'd show you that in case you would like to use that in the future. But let's just kind of go back to our regular y equals 2x. Right, it goes through the origin because it doesn't have a y-intercept. There's no, or sorry, the y, because the y-intercept is 0, sorry. And we can see here that it is going up pretty quickly. But when I put in the next one, y equals x, there's our second function, and that slope, because we decrease the slope, all right, our black line isn't as steep as the purple. And this will hold true for the next one as well. Y equals 1/2 x. Again, to put this into Desmos, you do 1 divided by 2. And then we have to kind of hit the little right arrow and move our cursor from the bottom to the side, and then we can put our x. And we see that one comes in red, and it's even more flat than the other two. So as we decreased our slope, right, our line became less steep. So let's get our sketches in here. We had y equals 2x, which would kind of look, in this case, like this. Y equals x, which kind of looked like that. And y equals 1/2 x. I'm going to exaggerate them a little bit. But we can see each time we lowered our slope, that line became less steep, or you could say more flat. All right, well, what does that mean? So let's answer our questions. What happens to the line as the slope decreases? All right, we just said that. When the slope decreases, the line becomes flatter, right? Or you can say it gets less steep. All right? It approaches a horizontal line, if that makes sense. And the next question, we're going to kind of jump there. Write an equation of a line that would be horizontal. What is the slope? Graph this line to check the line is horizontal. All right. Well, we know from our second lesson, I believe, or it might have been the first, that there's kind of 4 different lines that we're going to see. There's going to be lines that are up to the right, and those lines have a positive slope. We got lines that go down to the right, and those have a negative slope. But lines that are perfectly horizontal, all right, that's we did talk about, that was our third kind of example in our lesson. And what we talked about is because our slope is equal to the rise over the run, horizontal lines move exactly left and right. They never go up, they never go down. So there is no rise in a horizontal line because they go straight across. And in an equation, if you try to do 0 divided by any number, you will always get an answer of 0. So horizontal lines just have a slope of 0. It says graph the line to check the line is horizontal. So now we actually have to figure out an equation. Well, if we know that the equation of a line is y equals mx plus b, if our slope is 0, well, 0 times anything will just become 0. So 0x, right, that just disappears. And you're left with y equals b, which is the y-intercept. So depending on where I want my y-intercept to be is what my equation will be. So for example, if I want a y-intercept to hit at 5, and I'll just go y equals 5. And you can see this line is perfectly horizontal across at 5. Right? If you want the line to intersect at -2, you would say y equals -2. And there goes our green line, all right, at -2. All right, so let me just kind of graph this one here. Again, when I'm on my iPad, it's very hard to use a ruler. I would like you to kind of use a ruler when you're doing this on your own. But that equation there is y is equal, right, to, let's see, 5. I guess technically it'd be 1, 2, 3, 4, 5, 6, 7, 8. Technically it'd be y equal to 8 if I'm counting up on the y-axis there. And again, if I did another one, and let's try to do this as neat as possible. This line here, that is y equals -2, because that's where it hits our y-axis. Because these have no rise, right, that's why they have a slope of 0. So it says write an equation of a line that would go down from left to right. Graph the line to check this. So we know if it goes down to the right, again from our first note, this is kind of like a self-check note. If it goes down to the right, we know it has to be a negative slope. So as long as our equation is in the form y equals mx plus b, where our slope is negative, all right, this should work. So my favorite number is 7, so I'm going to choose y equals -7x plus 7. All right, so that I'm pretty confident that that line is going to go down to the right because I have a negative slope. So let's graph it just to double check. All right, y equals -7x plus 7. And as you can see, just like I said, it's going down to the right. It's pretty steep because it has a slope of 7. And because it's adding 7, our y-intercept is at 7. All right, so we can kind of sketch that here. All right, 1, 2, 3, 4, 5, 6, 7. There's my 7th point, and it's very steep, so I'm just going to draw a graph that looks like that. And there we go. There's a quick sketch. Let's go to the next question. It says, what must be true of the slope of a line that goes down from left to right? So we just said that it has to have a negative slope, right? And that says, what do all lines with positive slopes have in common? All right? Positive slopes always go up to the right, and all lines that are negative all go down to the right. All right, but someone might just say, if here's an example, you could say, here's a positive graph, and they say, instead of that's going up to the right, could I say that's going down to the left? And I'm going to say, no. You cannot say it's going down to the left, because once we get into real-world examples, right, the bottom axis is normally time. And time, you can only move, all right, in one direction, forward. So we're always going to say either we're moving up to the right or we're going down to the right. Okay? And there's that. So let's move on to the next part. It says graph the following lines on the same grid and then answer the questions below. All right, so let's pull out the slope. That's the easiest thing that we can do right here. Just spruce it up, change up the color. So this first one, here's our slope, 1/2, 1/2. And our second one, let's identify our slope again, is 1/2. And our third one, once again, is 1/2. Now again, you're going to see some overlap, and I'm doing this on purpose because I want you to make sure you remember certain parts of lines, all right, that I think are the most important for you to know, kind of to do well, not only in this course, but for future years, grade 11, and possibly grade 12. If you want to take a math credit, because it is not compulsory for your last year of high school. You only have to take it up to grade 11. So I've identified the slopes are all the same on all of these. The only thing that's different is our y-intercept. We can see that this one only has +0, so it's going to have a y-intercept of 0. The next one's going to have a y-intercept of -3, sorry. And the last one will have a y-intercept of +5. All right. And I'm going to graph them. I think we're all going to know what they look like because we've done lots of practice with this yesterday. But if I do y equals 1/2 x, oh, that's the multiplication. There we go, 1/2 x. And there's the first one. All right, there's our line. The next one, though, if I do y equals 1 divided by 2x, and I think it was -3? -3, yep. -3 and then +5, okay. So then we'll go, oh, sorry. Here we go. -3. We can see that line has been moved down 3. But because it has the same slope, all right, these lines stay the same. They stay the same distance, and in math we call that parallel lines, right? They kind of look like train tracks, right? They will never touch. And again, for the next one, y equals 1/2 x plus 5. We're going to see this one in blue has been moved up. It now has a y-intercept at 5. All right. But all three of these lines are parallel because they have the same slope. They never hit, no matter how much I go down this line. Right, I'm in 850 as my x value. The distance between those lines has stayed the same the entire time. Let me come back. Holy, there we go. And we're back. So let's answer the questions. Will these three lines ever intersect? All right. I guess first I should just draw them in. Sorry. I'm getting ahead of myself here. All right. Actually, it doesn't ask us to sketch. Graph the following lines on the same grid and then answer all the questions below. All right, we graph them on Desmos, so that's good. You don't have to redraw them. You can if you'd like. And if you do, just make sure you label them, and they should look something. 1, 2, 3, 4, 5. And then the other one is at -3. All right, so there's our three lines. So this is A, this is C, that one is B. All right, so will the three lines ever intersect? I'm going to say no, and this word's very important, no, because they are all parallel. All right, so lines with the same slope are parallel, which means they will never touch. Never. All right? No matter how far down or how far ahead you go, those two lines will never intersect or touch. All right? So I'm just going to write it all on one slide. I know we just said this, but that's the name given to lines that never intersect. They're called parallel lines. And what do you notice with the slopes of the three lines? Like we said, the slopes are the same. All right, last example, or second last example, sorry. We have these two lines, one in red, one in blue, and they're giving us the equation of the blue line, I think. Yep, negative 2x plus 1. They're giving us the equation of our blue line. They're saying write the equation of the line that is parallel to the given line. So we have to find the equation of the red. All right, and we can tell that these two lines are parallel, one from looking at the picture, but even if we can't tell from looking at the picture, we can figure out the slope by, again, picking 2 points. So here's 1, and here's 2. So if you're not 100% sure, this is a good thing to check. And my slope is my rise, which is going down 2 and over 1. Right? So when I tested, if I wasn't 100% sure, my slope would be negative 2 over 1, which equals negative 2. And that slope is the same as the slope in our example. So we already know the lines are parallel. What we have to do is we have to figure out what's the equation of this line, the red line. Well, remember, the equation of a line is y equals mx plus b. So if they're parallel, they have to have the same slope. So we'll have negative 2x. And the b value is simply the y-intercept. Where does the red line hit the y-axis? And we can see it hits right here at negative 6. So our equation will be negative 2x minus 6. All right, and there we go. That's it, done. There's our equation of our line. Please make sure, remember, if something's going down to the right, you always have a negative slope. Last one, last thing. Write the equation of one line that satisfies the given conditions. All right, so you can write anything you like. There is a limited number of right answers here. But if something is parallel, all right, what we need to remember today is parallel means they have the same slope, or we can say the m value. All right, so if we want a line that's parallel to 3x plus 4, well, our slope is 3. So in our equation, we're going to have y equals 3x. We could say plus 1. That would be an answer. Y equals 3x minus 252. That's also parallel. Or we could just say y equals 3x. Y equals 3x minus 0.1. Right? All of these are examples of parallel lines because every single line shares the same slope. Now, just make sure that if I wrote y equals 3x plus 4 again, now those are not parallel lines. They are identical. You just wrote the same thing twice. And those lines would just be right on top of each other. So they're always intersecting. So that is not a valid answer. Right? We can't just write the same equation twice and say they're parallel. All right, so don't try that. You can't do it. So there's that. There's part A. Part B, we have it saying steeper than the line, 2x minus 1. So the word steeper means a larger m value. All right, so it's got to be a bigger number than 2. So as long as I choose something bigger than 2 for my slope, I'm going to be okay. So I can do y is equal to 3x minus 1. Y is equal to 100x minus 1, or minus 10, let's say. All of these are examples of a line that is much steeper because their m value, or their slopes, are all larger than the one in the example. All right, some might be like, well, what if I put a negative number there? Now, let's say y equals negative 2x. It's just the opposite, going in the opposite direction. But I could have wrote y equals negative 3x, let's say, plus 1. because that's going to be a steeper line. It's negative, but it's going to be steeper. So would y equals negative 1,000 x minus 10, or y equals negative 100 x plus 57. All right, all of those would be examples, but in my opinion, if they're going to give you a positive slope in the question, stick to positive slopes in your answer. All right, they're all right, but this makes more sense. Now, the last one has the same y-intercept. Now, remembering y equals mx plus b, the plus b part is our y-intercept. So that means that positive 5 is the y-intercept in this question. So as long as our equation ends with plus 5, we can choose any m value we want. All right, so we could lay 2x plus 5, y equals 2/3 x plus 5. These all have the same y-intercept, or even y equals positive 1/3 x plus 5. Right? There's an unlimited number of choices, but hopefully you're seeing how I'm getting this answer. All of these share the exact same y-intercept. All right, there's today's lesson, or this morning's lesson. Please go check the work associated with it and give it your best try. And as you know, you can let me know if you have any questions. All right, have a great day. Take care.